Hello, math lovers. In today's lesson, I will show you a fast and easy way to solve simultaneous equation using the elimination method. Yes, the elimination method. If you ever struggled finding the values of x and y, a and b, m and n, or any variable, any two variables using the elimination method, then this lesson will really make your day. So grab your pen and your book. Let's dive in. Now, I have devised some few steps which will which we will go through to solve any simultaneous equation using the elimination method. All right. When you are posed with any simultaneous equation that demands that you use the elimination method, then you go through this series of steps. All right. So the first step is saying label the equations. That is, you label the equation 1 and equation 2. After labeling, look for matching coefficient. Now pay attention. When they talk of matching coefficients, then they mean if the coefficients are same. If the coefficients are same means we have 2x with the first equation and another 2x in the second equation. All right. Or when they are opposite. When they are opposite. Why opposite means that the coefficient of x in one equation is negative x and the other is positive x. So even though we have two there, but the signs are not the same. The operational signs are not the same. So whenever they are like this or they are like that, we consider them to be matching coefficients. We have 2 here, 2 there. It means they are the same. We have negative 2 here and positive 2 here. They are opposite. Any of these are considered to be matching. So this is matching and that one too is matching. So that's the meaning of matching coefficients. After identifying the matching coefficients, we will then add or subtract to eliminate the variable with that matching coefficient. Afterwards, we will solve for the remaining variable and then we substitute the result back into any of the equations and then we get the other variable. So it may sound confusing seeing it like this. Let's put it into practice. Now, this is a simultaneous equation involving the variables x and then y. And we are told to solve that system. In other words, we are told to solve for the values of x and then y in these two equations using the elimination method. So far, this is a simultaneous equation. You can use other approaches, but in this case, we are using the elimination method. Yes. So to resort to the elimination method, we will solve this question along with the following steps. So the first step is saying that if you are facing a question like this, label the equations. So I will bring my solution. And label the equation because they are just there without labels. We have 2x plus 3y is equal to 12. And I will label this one as my equation 1. I have another 2x plus y is equal to 6. And I will label this equation number 2. So we are done with the labeling. We go on to the next step, which is saying look for matching coefficients. And we talked about it previously that to say matching means whether the coefficients are the same, 2x, 2x, or they are opposite. One is negative and one is positive. So if they are all the same, then they are considered to be matching. When they are also opposite, one is negative with the same absolute number and the other is also positive, then they are considered to be also matching. So in this case, we will look for the variable with matching coefficient. Let's come here. We check for the coefficient of x. In the first equation, it is 2. And we check for the coefficient of the x in the second equation, it is also 2. So it's qualified to be called same and it is matching. Let's check for the other variable. The coefficient of y here is 3, and the coefficient of y here is 1. Because they are not the same, they are considered not to be matching. And we can only eliminate variables with matching coefficient. In this case, we will eliminate the variable x. Why? Because it is the variable with the matching coefficient. That's the only one we can eliminate at this point. All right. So after identifying which variable to eliminate, in this case, we are identified that we will eliminate x. Then, will you add the two equations, or you will subtract the two equations to eliminate that x? That is what I have simplified over here. If the coefficient, the first coefficient is negative, and the second coefficient is also negative, then we are subtracting the equations. If the first is positive and the second is positive, we are subtracting. On the other hand, if one is negative and one is positive, then we will add the equations. In this case, the coefficient here is having plus, and the coefficient here is also having plus. It means that it qualifies in this stage, the first stage. So we are subtracting the two equations. So let's write it. We are subtracting equation 2 from equation 1. We can write it as subtract equation 2 from equation 1. Yeah. Which is the same as saying equation 1 minus equation 2. The same thing. The same thing. All right. So as we are given the instruction, let's go on to subtract the two equations. First equation minus second equation. There's our first equation. 2x plus 3y is equal to 12. They said minus, so minus. I bring my big bracket and I write a second equation, equation 2, which is 2x plus y is equal to 6. That is my second equation. We are subtracting the usual way. So now we have 12 minus 6, and that is giving me 6. I bring my equal to sign. Remember that the goal or the motive of doing all this is to eliminate one variable, which we have decided to eliminate the x because of the conditions they satisfy. Now 3y minus y is giving me 2y. We come here, 2x minus another 2x, and you know it is definitely going to be 0. So we can choose to bring the 0 here, plus 2y is equal to 8. We can also choose to ignore it because 0 means nothing, so we can ignore it. At this point, we have been able to eliminate the x, and it is left with the y. Is that after adding or subtracting, we have to solve for the remaining variable, and this is the remaining variable. So we have to solve for the value of y. To get the value of y, we decide to divide both sides by the unwanted coefficient. That is 2. Divide here 2 by 2. This cancels that. 2 divides itself 1 and divides 6 3 times. At the end, we are having y to be equal to 3. Now we have the value of the remaining variable y, which is 3. After getting the y, we have to substitute x into any of the original equations. Any of them. We can choose to substitute y into equation 1 or into equation 2. In this case, I will substitute y into equation 2. So I say put y is equal to 3 into equation 2. Where is my equation 2? I quote it. This is equation 2. 2x plus y is equal to 6. Is that wherever I see y, I replace it with 3. So this is the same as having 2x plus I bring the 3 to be equal to 6. Now I collect two items since I am on my way to find the value of x. We subtract 3 from both sides. So subtracting 3 from here and subtracting 3 from there. This 3 will cancel that 3, and we are now having 2x is equal to 6 minus 3. 6 minus 3. So we say 2x is equal to 6 minus 3 is 3. 6 minus 3 is 3. And then because we are finding the value of x, we divide both sides by 2. This cancels that, and now we know that the value of x is equal to 3 on 2. So now we have the value of y and the value of x. These are the two values that will satisfy both equations. If I put y there and then 3 over 2 there, the answer has to give me 12. And if I put them in this one, they also have to give me 6. That's the meaning. So the values of x and y that satisfy these two equations are x is equal to 3 on 2 and y is equal to 3. So you could see how simple using the elimination method works. So this is how we go about solving simultaneous equations using this elimination method. Let's deal with a second example to broaden our understanding. Let's deal with a second example. I hope I can clean this at this point. Yeah. This is our second example. Solve the system to 3x plus 4y is equal to 18. And then 2x minus 4y is equal to 2. Now with questions like this, the first thing is to label our equations. We have to label our equations. We have to label our equations. So let's label it 3x plus 4y is equal to 18. We give it our equation 1. And then 2x minus 4y is equal to 2. We label it equation 2. We are done with the first step. After the first step, they said we have to look for matching coefficient. Matching coefficient. In this, let's check for the coefficient of x. The x here is having 3 as a coefficient, and the x in the equation 2 is having 2. It means they are not matching. We can't eliminate them. Let's check for the y. The coefficient of the y in equation 1 is positive 4. And the coefficient of y in the equation 2 is negative 4. Yes, we consider this to be matching because they were part of the categories. They said it's either they are the same or they are opposite. They are all 4, 4, just that one is having positive and one is negative. So we consider this to be matching coefficient. So since they are matching, we can eliminate the variable y. So now we know we are eliminating variable y. Now, after identifying what to eliminate, you decide whether you are adding the two equations or you are subtracting them. We mentioned that when the operational signs or symbols are the same, we subtract. But when they are not the same or when they are different, we add. We have positive here and negative here because the coefficients are having different operational symbols or signs. We are adding the two equations. So we say add equation 1 and equation 2. The first one we subtracted because the two coefficients had the same operational signs. Yeah, this one they are different, so we add. So it means that equation 1 plus equation 2. That's the meaning of what we've written here. So let's try and add them smoothly. Equation 1 is 3x plus 4y is equal to 18. This is equation 1. Plus, because they say we are adding the two equations. The second one is 2x minus 4y is equal to 2. And we are adding. This is equation 2. Yeah, we are adding. So 18 plus 2 is 20. We bring our equal to sign. 4 plus minus 4. So 4y plus minus 4y. You can see that this is the same as having 4y minus 4y. This cancel and we are having 0. So we can choose to ignore the results or bring our 0 here. 0. Then we bring our 3x plus 2x. This is giving me 5x. So now we have 5x plus 0 is equal to 0. That's 20. We know it is the same as having 5x is equal to 20. Now, after eliminating y, we are left with x to find. So let's find x by dividing both sides by 5. This cancels that. Now we are having x to be equal to 5 divides itself 1 and divides 24 times. So we are having x to be 4. After finding the remaining variable's value, we substitute it into any of the original equation, any of them. You can choose to substitute it into any of the original equations and it won't change the results. So we will substitute it into equation 1. So we say put x is equal to 4 into equation 1. So we are putting it into equation 1. Where is equation 1? Equation 1 is 3x plus 4y is equal to 18. Wherever we see x, we replace it with 4. So this is the same as having 3 times 4 plus 4y is equal to, plus 4y is equal to 18. 3 times 4 is 12 plus 4y is equal to 18. So now we are having 4y. We subtract 12 from both sides, and then we are having 18 minus 12 on that side. This will result in 4y is equal to 18 minus 12 is 6. We have our 4y to be equal to 6 over here. I just wanted to repeat it so you see it clearly. Now we are looking for the value of y. So we divide both sides by 4. 4 cancels that 4. And then we are having y to be equal to 2 divides 4 2 times and 2 divides 6 3 times. So at the end we are having 2. So we can now say that the values of x and y that satisfy these two equations or that satisfy this system are x to be 4 and y to be 3 2. So these are the values that will make the equations true. So this is how we go about solving simultaneous equations using the elimination method. Before I leave, I have to give you something to try so you keep yourself busy. So let's try this. Let's try this. So try this whilst we are away. In part 2, we will focus on how to eliminate variables when the coefficients are not matching. And it's super easy when you see it. So we will do that in the part 2. If you found this video very helpful, kindly drop your questions, your answers, and your suggestions in the comment section. It's really helpful. And then subscribe for the part 2. Thank you for watching. Bye bye.